Test for equality of variances. Parametric and non-parametric Levene's test in SPSS. Hi and welcome. Equality of variances is a necessary assumption for some parametric and non-parametric statistical methods. For example, an underlying assumption for both analysis of variance, which is a parametric method, and the Kruskal-Wallis one-way analysis, a non-parametric method, is that the groups compared have highly equal variances. And as a consequence, we must be able to test for equality of variances in both normally distributed data and non-normally distributed data. So, if you have normally distributed data, you should perform the parametric Levene's test. And if you have non-normally distributed data, you should perform the non-parametric Levene's test. In this tutorial, I will show you how to perform both using SPSS, and I will show you the necessary references and how to write out your results. How to perform the parametric Levene's test. In this example, I have two variables, gender and exam scores, and I know for a fact that my data are normally distributed. In SPSS, the Levene's test for normally distributed data is built into the ANOVA procedure. So let's run ANOVA. In the menu of SPSS, click on Analyze, select Compare Means, and then One-Way ANOVA. Put your data variable in the dependent list. In our example, it's exam scores. Put your groups in the factor field. In our example, it's gender. Click on Options and select Homogeneity of Variance Test, and then click Continue and OK. Focus on the test of homogeneity of variances and the p-value. And as you know in SPSS, the p-value is always labeled SIG. The null hypothesis for the parametric Levene's test is that there is an equality of variance. If the p-value is below 0.05, we reject the null hypothesis and assume that we don't have equality of variance. If it is above 0.05, we keep the null hypothesis and assume equality of variance. If I perform the parametric Levene's test, this is how I would write out my results. How to perform the non-parametric Levene's test. In this example, I have two variables, hometown and final exam score, and I know for a fact that my data are not normally distributed. In SPSS, it's not yet possible to execute the Levene's test for non-normally distributed data in one step. We need to prepare our data by taking some initial steps to create three new variables with ranked data, group mean ranks, and deviations from those mean ranks. Step 1. Create the ranked data and put them into a new variable. This is how I do it with my example data. In the SPSS menu, select Transform and then Rank Cases. Put your data into the field Variable. In my example, it's Score. And then click OK. SPSS will automatically create and label a new variable, R-score, where the letter R stands for ranked. In this new variable, each student has been given an individual rank based on their individual exam scores. Students with low exam scores are given lower rankings than students who performed better. Step 2. Based on these individual rankings, it's time to determine the mean ranks for each group. So, yet another variable has to be created in SPSS, and this is how I do it. In the menu, select Data and then Aggregate. Put the variable previously created, R-score, into the field Summaries of Variable. Click on Function and select Mean. This will collect the numbers in the variable R-score and aggregate them in the form of mean values. Put your groups in the field Break Variable, in our example Town, and then click OK. SPSS will now automatically create and label a new variable. This time it's called R__mean_1. In this new variable, each student has been given a value based on their group. All members of the same group, or town in my example, will have the same value. It is the group's mean rank. Step 3. Create a third variable containing a measure of each individual's deviation from his or her group's mean rank. This measure cannot contain negative values because the Levene's test is performed on positive measures. For each student in my example, I subtract the individual rank value from his or her group mean rank. And to perform this and to create this third variable, and to also make sure that all values are positive, I do the following. In the menu, select Transform and then Compute Variable. Then, under Target Variable, provide a label for this third new variable. Let's call it INDDIF, which will be our abbreviation for individual differences. In the field Numeric Expression, enter the formula R_mean1 minus R-score. And before we click OK and execute this computation, we must instruct SPSS that we only want positive values, i.e. that any minuses must be transformed into pluses. So in the field function group, click once on All and then select the entire expression R_mean1 minus R-score and double-click on ABS in the field Functions and Special Variables. ABS is an abbreviation for absolute value, which is never negative. And as you can see, the expression will change. You have now instructed SPSS to transform all results to absolute values. Click OK and the third variable is now created, and it contains individual measures of spread, i.e. how far each individual is to his or her group's mean. Step 4. Now it's time to perform an ANOVA on these individual differences. In the menu, select Analyze and Compare Means, and then One-Way ANOVA. Put individual differences in the field Dependent List and the variable Groups in the field Factor. Click on OK to execute. The null hypothesis is that there is an equality of variance. If the p-value is above 0.05, we keep the null hypothesis and assume equality of variance. However, if the p-value is below 0.05, we reject the null hypothesis and assume that the differences in variance or spread between the groups are statistically significant. If I perform the non-parametric Levene's test, this is how I would write out my results. Here are the references for this tutorial. When it comes to the Levene's test for normally distributed data, you can pretty much use any statistical handbook. I like Martin and Bridgmont's from 2012. When it comes to Levene's test for non-normally distributed data, use these articles by Nordstocke and Zumbo and Keynes and Saklovsky. Good luck with testing your data in SPSS for equality of variances, either through a parametric or a non-parametric Levene's test.